Hello, my name is Khalil, and today we're going to be talking about our capstone project in NucSurv. My name is Khalil,
My name is Karamvir.
and we are both students at the engineering physics department. Motivation. The independent electricity system operator, which is in charge of operating the electric grid in Ontario, projected that Ontario needs to double its nuclear generation capacity by 2050 to meet net zero goals. So, as we scale up nuclear generation and we carry out ongoing refurbishment projects, the volume of low-level waste is steadily increasing. The challenge at hand involves the efficient management of this waste, which is currently relies heavily on manual labor, making it costly and time-consuming. So, therefore, we partnered up with a company from the nuclear industry that focuses on sorting and dealing with this low-level waste. And we chose to automate one of their processes. So our solution revolves around automating the waste bin surveying process, which is the bin that the nuclear waste comes in. This will enhance both safety and efficiency. A tool like a NucSurv could be an asset to our partner in scaling their ability to scan a lot of nuclear waste bins in a shorter amount of time.
So here are our goals for Capstone project. So we want to provide automated CNC surveying of nuclear waste bins, display surveying data on a plotting software highlighting the hotspots of contamination, be modular to accommodate different bin sizes and different nuclear detectors, reduce surveying time, and maintain the safety protocols already set up in place. And lastly, utilize readily available components for future development and use.
So for timeline, we first had to sit down with the industry partner and establish a contract with deliverables. We engage in conversations with technical experts from the sponsoring companies, Health Physics, and McMaster Engineering Physics Department. We designed the preliminary mechanical drawings, electrical schematics, and the control flowchart to show how the project would work. We developed integration plan between the automation and the data acquisition requirement. We built and tested a prototype design with served that served as a first pass proof of concept model.
So here you can essentially see our prototype model developed in November of 2023. You can see it's just one side of our multi-sided gantry surveying system. We used open loop control using G code, so there was no closed loop feedback for automating our gantry, and we were able to move it up and down and left and right with the use of stepper motors, which were controlled by Arduinos, and we had a temperature sensor in place of our radiation detector as we didn't have it at the time, and we didn't have a plot, but we were still outputting values to the serial monitor.
Then in March of 2024, we had our engineering physics expo, and by that time we managed to scale up the prototype that we built in first semester. This system had a closed loop control system controlled by Arduinos and stepper motor drivers to drive the motors. And by that time we had acquired a GM tube type of detector and managed to have a plot. On the Raspberry Pi.
So now looking at our engineering capstone expo and the capstone model here, we have a two-sided automated gantry system. Again, we're using extruded aluminum and closed loop control with limit switches and stepper motor drivers. We have, we're able to actuate our gantry up and down and move our detector left and right. And here on the right, you can see the plot that we had from one of our surveys or scans. And we had our radiation source right in the middle. And you can see that's where the hotspot is, as that's the brightest color. So in that area would be the highest source of contamination per that side.
Some of the key takeaways after the Capstone Expo. So we managed to achieve a closed loop control automation system successfully. The Arduino-based GM tube counter was able to effectively display counts with a material used as a sample radioactive target at different locations on the survey, and that's what the hotspot was on the previous slide. The data acquisition was done with the Raspberry Pi utilizing Python code and plot function, uh, plot library in Python. The gantry frame maintained its structural integrity throughout the testing and demoing process.
Lastly, we just wanted to give a big thanks. So a big thanks to the McMaster Engineering Physics Department, the Capstone class staff and instructors, and also our sponsoring team for being very supportive and offering great mentorship along the way. It's been very rewarding and amazing to work on a project of this magnitude. And thank you for having that experience.